In this video, I will explain how to calculate resultant displacement. So let's jump right into an example. This says, a bird flies 10 meters north, then flies 4 meters east, then flies 15 meters south, then flies 3 meters east. Calculate the magnitude and the direction of the bird's resultant displacement. So let's go ahead and just sketch out this situation. Let's say this bird starts right here. They fly 10 meters north, so let's say 10 meters north, and then they fly 4 meters east, so let's say they go this way for 4 meters. Then they fly 15 meters south, so they go 15 meters south. And then lastly, they go 3 meters east, so they go east again. And we'll say that's 3 meters. And we'll say this is the ending point of the bird. So it says calculate the magnitude and direction of the bird's resultant displacement. So what we need to understand is that when we're talking about a resultant vector, that's simply a vector that starts at the starting point and ends at the ending point of this bird's journey. So if we were to draw the resultant vector, it would look like this. Just a straight line that starts at the beginning and ends at the end of the bird's journey. Now our question is, what is the magnitude of this vector? In other words, what is the length of this vector? So how can we find that? Well, the trick that we're going to use is we're going to try to draw a right triangle in which the resultant vector is the hypotenuse of the right triangle. So notice what we can do. We can draw a straight line like this. This is the total displacement in the x direction of the bird. And then we can draw a straight line like this to form the third side of the triangle, and that's the total displacement in the y direction. So for the x direction, notice that the bird starts here. He moves 4 meters east and then another 3 meters east. So the total displacement in the x direction, let's write that right here. We'll say the delta in x, the change in the x, that's going to be 4 plus 3, which is 7. And we'll say meters. So altogether, the bird moves 7 meters to the east. So this side of the triangle right here, this is 7 meters. And then this side of the triangle, this describes the total displacement in the y direction. So notice that first the bird goes 10 meters north, but then he comes back and goes 15 meters south. So the total displacement in the y direction, let's say the total change in the y, that's going to be a positive 10 and then minus 15 since he goes south. So 10 minus 15, that's negative 5 meters. So the total displacement in the y direction right here is negative 5 meters. So now notice we've formed a right triangle where this is a 90-degree angle. And the resultant vector right here, this is our hypotenuse of the triangle. So to find the length of the hypotenuse, which is the magnitude of the vector, notice what we can do. If we have a right triangle like this, and we want to find the hypotenuse, the Pythagorean theorem says if you call this side C, and let's call this side A and this side B, C squared must be equal to A squared plus B squared. So it becomes very easy to figure out what C is. So let's fill in the values that we know. We'll say C squared is equal to A squared, so in this case A is 7, so we'll say 7 squared, plus B, so B squared, that would be negative 5 squared. And to solve for C, we just take the square root of each side. So we get C is equal to the square root of 7 squared is 49, negative 5 squared is positive 25. So we get the square root of, that's 74, and that turns out to be about 8.6, and we'll say meters. So the magnitude, in other words, the length of this resultant vector is 8.6 meters. So let's go ahead and box that in. That's our magnitude of the resultant vector. Now we also want to know what is the direction of the resultant displacement. So when we talk about direction, we're always talking about what is the angle relative to the positive x-axis. So if our bird starts right here, if we imagine that the x-axis is right here, and this is the positive x-axis, when we're trying to find this angle right here, we're trying to figure out what is the angle relative to the positive x-axis. So what is this angle? So how can we find that? Well, the trick is we can first find what is this reference angle right here. So to find that, here's the formula we use. We say the angle is equal to the inverse tangent of the displacement in the y direction divided by the displacement in the x direction. So that's equal to the inverse tangent of the displacement in the y direction is negative 5. Now, when we're calculating this inverse tangent value, we always use positive values. So we're going to use a positive 5. and then the displacement in the x direction is 7. So if you punch this into a calculator, the inverse tangent of 5 divided by 7, and by the way, make sure your calculator is in degree mode, that comes out to 35.54 degrees. So that describes this reference angle right here. But remember, we want to know what is this angle right here. So relative to the positive x-axis, if we go counterclockwise, what is that angle? Well, if we went all the way around a circle, that would be 360 degrees. So to find this angle, we just need to do 360 minus this reference angle of 35.54. So our final angle is just going to be 360 degrees minus that reference angle of 35.54 degrees. And that turns out to be 324.46 degrees. So that is the direction of the bird's resultant displacement. So once again, we had this bird that went on this long journey, but ultimately the final displacement, it had a magnitude, or in other words, a length of 8.6 meters, and the direction counterclockwise to the positive x-axis, this angle was 324.46 degrees.